This is Algebra 2 with Trig, 1C.1b. We are going to be solving quadratics by factoring. You can use factoring to solve certain quadratic equations. You can't use factoring to solve all quadratic equations, but you can solve some quadratic equations with factoring. A quadratic equation in one variable can be written in the form ax squared plus bx plus c. We would often consider that to be standard form. These solutions of a quadratic equation are called zeros of the equation. We're going to call them x-intercepts. We're going to call them zeros. We're going to call them solutions. We're going to call them all those different terms. If the left side of our equation can be factored, then the equation can be solved using the zero product property. So what is the zero product property? If you have two terms, A and B, so think about two numbers in your head. If you have two numbers and you know that they multiply to be zero, so you're thinking right now of two numbers that multiply to be zero, then you know that A would have to be zero or the B equals 0. There's no other way to multiply to be 0. Either this term is or that term is 0. So when you take a look at intercept form, two sets of parentheses, either this A term is 0 or the B term calculates out to be 0 when you plug in your x. So you set it equal to 0 and you set x plus 2 equal to 0 to help you determine what the x value has to be for that to turn into 0, because one of those answers has to be right. So let's come on down here and try it. So these are called roots. That's another term that we can use, called roots of the equation. Those are your solutions. Those are your zeros. Those are your x-intercepts. Find the roots of each equation by factoring. So notice, this is an equation. This has an equal sign. Yesterday when we practiced factoring, we did not have equal signs. We just had an expression and we said factor that. Today we have an equal 0. So that implies that we need to go a step further. We need to solve. This one we solve for the letter x. So we're going to first factor. So I'm going to look at this. In my mind at least, I'm thinking about what multiplies to be negative 15 and adds to be negative 2. You're thinking this in your head. You're okay to write it down. You know the two signs have to be different. For you to multiply to be a negative 15, one number has to be positive and one number has to be negative. The larger number has to be negative for you to add to be a negative. So negative 1 and 30, negative 3 and 5 are the only two ways that we can multiply to be negative 15. With the larger number positive, with the smaller number, oh, I wrote that backwards, didn't I? I said the larger number has to be negative. I'm sorry. So the larger number has to be negative. This adds to be negative 29. I'm not interested in that. This adds to be negative 2. Oh, perfect. I found it. You can probably just do that in your head. But I'm showing you the options of what you have to be thinking in your head. That can be beneficial. So since this has a leading term of 1, then we can just write this right into parentheses, x positive 3, x minus 5 equals 0. We have factored it apart. You can check this out by foiling it to see if you get what you started with. So next we're going to use what's called the zero product property. So we set both of our factors equal to 0. We subtract the 3 across and get x equals negative 3. And those are your two roots of the equation. You might even call them the solutions of the equation. You might call them the x-intercepts of the function. All right, let's come on down here and try this one. So we're supposed to find the roots. The roots are the same thing as the zeros. So I'm going to take my table. I'm going to use negative 20. I'm going to use 8. I'm looking for two numbers that have to be different from each other because they multiply to be a negative. And I know the larger number has to be positive. So this is going to be negative 1 and 20, negative 2 and 10. Hey, that's it. 3 doesn't go into that, 4 goes into that, but we don't even need to talk about it. We already got our number that adds to be 8. This one adds to be 1, that doesn't matter. This one adds to be 8, that's what we're looking for. This one adds to be 19. I'm doing that just to show you they all add to different stuff. We only want one of them. Only one of them will work. So now since I know my two values that multiply to be negative 20 and add to be 8, I can plug them into my parentheses. You don't change the signs when you put them into parentheses. Those are your actual terms. T minus 2, T plus 10. To do the opposite that we're talking about, that's going to occur when you set them equal to 0. And we add 2, add 2. Now you actually get the 2. That's the opposite. Now we subtract the 10, subtract the 10. Now we actually get negative 10. If you were to graph this, those would be your answers on your x-axis. Those would be your values of where it crosses the x-intercept. Okay, another way to ask the same question is to call it, what are the roots? But you might not have it equal to 0. First thing we have to do is make it equal to 0. If this has a b term, look at this equation. In standard form, we could call this 2 a b. ax squared plus bx plus c. This is our b term. And if we have a b term, then we have to bring everything to the same side of the equal sign. If it has two different types of x's, this is an x squared, this is an x, we have to bring everything over to the same side of the equal sign. So we have x squared plus 2x minus 35 equals 0. Now I'm looking for two things that multiply to be 35, negative 35, and add to be a positive 2. I know my two signs have to be different from each other. My larger number has to be positive if it's going to add to be a positive 2. So in our head, if we're not sure of the answer yet, we know my larger number is positive, so negative 1 and 35 negative 5, and 7. Those are the only ways to multiply to be 35. This one adds to 2, and this adds to something else other than 2. That doesn't matter. So this is the one we want. So I'm going to take my x and drop it into the parentheses. I'm going to take my 7 and drop it into the parentheses. Now I do my zero product property. And I add 5 to the other side. And I subtract 7 to the other side. Now I have my two answers. We can practice it one more time. So we're looking for two numbers that multiply to be 1 and add to be negative 1. Thank you. To multiply to be 1 and add to be negative 2. You know your signs have to be the same for this to happen. To multiply to be a positive number, they both have to be positive numbers, or they both have to be negative numbers, and that multiplies to be a positive. So in this case, they both have to be negative if you're going to add to be a negative. They can't both be positive. And that's the only way to multiply to be a positive 1 with negative numbers. That adds to be negative 2. There's only one choice. So we can say h minus 1 and h minus 1. So you do your zero product property. And yes, you get the same answer. And we're all done. Okay, the x-intercepts of the graph of y equals a, x minus p, x minus q, we've seen that before, are p and q. Those are your x-intercepts. Because the function's value is 0 when x minus p equals 0 and x minus q equals 0, the p and q are called zeros of the function. So on the flip side, page 6, we're going to find the zeros of these functions by writing it in intercept form first. There are multiple ways we could find the zeros of the function. You could try to graph it and see where it crosses the x-intercepts. That would be an obvious way. Okay, we could make a table and see what values are going to finally produce 0. It's kind of like graphing. Or we can factor. So we're just practicing our factoring a little bit more. So I'm looking for two numbers that multiply to be negative 28, that add to be 3. I like to make this T table to at least demonstrate numbers that have to go through my head. And if you're making a table, I would suggest for you to think about which signs you're going to be working with. You know that the two signs have to be opposites of each other, and the larger number has to be positive. Larger number is positive. I would suggest to start with 1, then go to 2, then consider 3. Does 3 go into 28? No, it doesn't go into 28. Does 4 go into 28? Yes, it does. Okay? Those are the only numbers that go into 28. So this is the only one that adds to 3. So we're going to be able to take our y equals x minus 4, x plus 4. We have written it in intercept form.
So you don't have to put it in
Now we're going to find the zeros. So now we have to set y equal to 0. And that's x minus 4 equals 0, and x plus 7 equals 0. So you're going to add 4, and you're going to subtract the 7. There are your two zeros of the function. First we wrote it in intercept form, then we factored it apart.
Can you just skip the stuff in the middle? Just like, since we know it's x minus 4.
Okay, we come over here to this side. Remember, whenever we make our table, we're thinking A times the C. Always A times the C. That is 4 minus 4. 1 times 4 is 4, and your B value is negative 4. You know your two signs have to be the same, and they both have to be negative to add to be a negative, and they will also multiply to be a positive. So we could say negative 1 and negative 4, negative 2 and negative 2. Those are the only ways to multiply to be 4. This doesn't add to what we want, but this one does. So because the leading coefficient is a 1, only because it's a 1, I can go right to it and drop my factors into the parentheses. And now I'm going to say that it's going to be 0 because I'm looking for the zeros of the function. And it's x minus 2 equals 0, and x minus 2 equals 0. Well, that's going to be adding to both sides and adding to both sides, so x equals 2. All right. So, just as we've talked about before, solutions to quadratic equations can be referred to as x-intercepts. We could put a whole bunch of words in that spot, actually. And they're also zeros of the function. They're called solutions. They're called roots of the quadratic function. If a and b are expressions and a times b equals 0, then we know a has to be 0 or b has to be 0. That was the zero product property. And that's what we're using to solve these. So, just more examples. Now look here at this one with x squared. I would suggest not to move the x squared to the right. I would move those to the left. Keep your x squared positive and move those other terms to the left. Add the 2x to the left, subtract the 8 to the left, and I have my equation written on the left-hand side. Then I can break it into my parentheses. What multiplies to be negative 8? That's going to be 4 and 2. I need larger numbers. That's going to be a positive 4 and a negative 2. When I look at FOIL, I get x squared. Negative 2 and positive 4 give me my 2x, and 4 and negative 2 give me my negative 8. That's an example of guess and check. You don't have to make the table. You can go right to the parentheses, and you can write in your values if you're pretty confident on what they're going to be. Then we use our zero product property. to come up with our two values that we've calculated. This guy here, if we want f of x to equal 0, then you're plugging 0 in for your function. When does this parabola equal 0 is the question. So we go to our parentheses. We know that the front terms have to both be x to get x squared. We know the last terms have to both be something that multiplies to be 8. Well, that can be 8 and 1, or that can be 4 and 2. So no factors are making this happen. So maybe you start to get nervous and you make your table to put us back to what we're comfortable with. We know that 1 and 8, 2 and 4, there's nothing else that multiplies to be 8. Nothing adds to be 12. So there are no values here. So in terms of factoring, it is prime. But find the value of x, there are no solutions. The factoring is considered prime, but the solve for x is no solution. Now we're looking at a rectangular vegetable garden in your backyard that has the dimensions of 15 by 10. So you have 15 by 10 in your garden. We know that the area of our garden is going to be 15 times 10, which makes 150. So the area of your garden is 150. You want to double the area. You now want the area to be 300. You're going to double the area of the garden by adding the same distance x to the length and the width of the garden. So we're going to say that x plus 15, we're going to add an x value to this dimension and add that same x to this dimension, and together they're going to be twice as big. So this was 15 plus x. This one is x plus 10. So you have this x value and 10 more. And together, when you multiply this larger amount, you're going to get 300. So what do the dimensions have to be? Well, we know to use the zero product property, we have to have it equal to 0, but right now it equals 300. So we're going to have to first factor, or actually FOIL this together. And there we have our standard form of the original shape. Okay, this is standard form. I guess it's not of the original, but it's with the additional x added on. Now we're going to subtract the 300 across. When you subtract, you get negative 150, and you get 0 on this side. Now we've got it down to a quadratic equation, but we have 0 finally on one side. So we have x squared plus 25x minus 150. So we're looking for two things that are multiplying to be negative 150. When you multiply the x's, you get x squared. And there's multiple ways to get to 150. We could try 15 and 10. But when you add the 15 and 10, the signs have to be different. We could do 5 and 30 to add to be 25. You have to have more positives than negatives. That multiplies to be 150, and that adds to be 25. Now we can use the zero product property. So we add 5 across, we subtract the 30 across. So to find my final dimensions, we're going to take the 5. We're not going to take negative 30. We're going to take the 5 and we're going to add it to our dimensions. So we're going to say 15 plus 5, so we're going to have dimensions of 20. We're going to take 10 plus 5, dimensions of 15. So 20 feet by 15 feet are 2 dimensions. Here we have a rectangle. We're going to find what x is if the area of the rectangle is 16. So to find a rectangle, you need to take the 2 dimensions and multiply them together, length times width. And that gives us our area. Now to solve this, we can't set them both equal to 16. So we're going to distribute subtract the 16 over. Now this one's trickier because there is no GCF. We have to deal with this 3. So 3 times 16, that's negative 48. That adds to be 2. Well, negative 6 and positive 8 multiplies to be negative 48 and adds to be 2. So I'm going to say 3x squared. I'm going to use these two as 6x plus 8x minus 16 equals 0. Circle your 2 groups. Factor out what you can. Oops, 8 times 2, if I factor, yes, 8 times 2, that makes 16. Now what's inside my parentheses is exactly the same, so I get 3x plus 8 and x minus 2 equals 0. So I'm going to use the zero product property to equal 0. Well, that's a plus, got to have your terms right. So what we see with this, when we subtract the 8 and divide by the 3, we're getting a negative dimension. We can't have a negative dimension in geometry. X can't be a negative number, so we don't consider that a solution. So 2 is the value of x that could make this work. If this was a 2 and this was 6 plus 2, this would be a 2 and an 8, which multiplies to be 16. All right, here's a bit of a review question. The internet provider sells internet service for $30 a month to 1,500 customers. So what we're looking at here is $30 a month. There's our price times the number of items. That's 45,000. We want to maximize that. When we increase the price to 31, the number of customers is going to decrease. So we're going to say 30 minus $1 a whole bunch of times. So we don't know if it's 1 times 2, 1 times 3, 1 times 4, 1 times 5. And every time we do that, we are going to, it's an increase, I'm sorry, we're going to add $1. And when we do that, we're going to decrease by 25 as many times as we do that. That's going to equal our revenue. So that's our maximum equation. So we take our calculator and we're going to go to y equals. You might want to go to second plus 712 to clear it out. We'll do 30 plus x and 1, or actually 1500 minus 25x. And we want to go to second table. How much should the company charge in order to maximize revenue? Well, to maximize revenue, I'm looking at our numbers and they're going up, still going up. Oh, now it's going down. So there's our maximum value. So what is the maximum monthly revenue? That's our 50,625. Now, how much should the company charge? Well, when x equals 15, so our charge amount is this. So we're going to say 30 plus 15. That gives us $45. $45 is what we should charge.